Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC B1175 indicates a malfunction in the fuel level sensor circuit, specifically concerning the fuel gauge sending unit. This component plays a crucial role in measuring the fuel level in the tank and transmitting this information to the gauge control module, allowing drivers to monitor fuel levels accurately. The fuel gauge sending unit is integrated with the fuel tank unit, making it a critical component in ensuring proper vehicle operation and avoiding fuel-related issues. When an open circuit condition is detected for a sustained period, the gauge control module registers this as an abnormality, triggering the DTC B1175. Understanding this code involves recognizing both the components involved and the vehicle systems they connect to, which are essential for troubleshooting and ensuring the vehicle runs efficiently. In the following slides, we will explore in-depth diagnostic steps, potential causes, and repair procedures for addressing this specific issue. The fuel gauge sending unit, which is integrated into the fuel tank unit, has the essential role of sensing the level of fuel within the tank. This unit generates a voltage signal proportionate to the fuel level, which it sends to the gauge control module for processing. The gauge control module interprets this signal and displays the fuel level on the dashboard, allowing the driver to monitor fuel availability. If there is an issue, such as an open circuit condition, the gauge control module triggers DTC B1175. This means that it either could not receive a signal or detected inconsistencies in the voltage, indicating that the sending unit may be malfunctioning. Given its location within the fuel tank, accessibility can often be challenging, making it critical for technicians to understand both its operation and its connections thoroughly. This DTC concerns the electronic communication between these units and the integrity of their circuitry. The potential causes of DTC B1175 include an open wire condition in the circuit, a faulty fuel gauge sending unit, or a failed gauge control module. An open wire condition signifies a disruption in the electrical connection, preventing proper communication between the components responsible for monitoring fuel levels. This could occur due to physical damage, corrosion, or loose connections, particularly where the fuel gauge sending unit connects to the gauge control module. A malfunctioning fuel gauge sending unit may also fail to provide accurate readings or become completely unresponsive, resulting in erroneous fuel level indications on the dashboard. Lastly, if the gauge control module itself has failed, it would not process the signals correctly, leading to the same diagnostic trouble code being stored. Identifying the specific cause is paramount for efficient troubleshooting and rectification. Symptoms of DTC B1175 typically include inaccurate fuel gauge readings, where the gauge may not reflect the actual amount of fuel present in the tank. In some cases, the fuel gauge may remain at zero regardless of fuel status, indicating a serious communication error. Drivers may also notice warning lights activated on the dashboard that signal fuel system malfunctions. Since this issue directly impacts fuel level readings, it can lead to situations where drivers unknowingly run out of fuel, potentially causing inconvenience and roadside emergencies. Proper diagnosis and repairs are essential to ensure that the vehicle operates smoothly and to prevent any misunderstandings regarding fuel availability. Awareness of these symptoms allows for timely intervention and effective resolution before the problem escalates. The first step in troubleshooting DTC B1175 is to turn the vehicle to the on mode. This action prepares the vehicle's electrical systems, allowing components, such as the gauge control module, to initialize properly. Following this, it is important to wait for at least 30 seconds to ensure that the system stabilizes and allows the gauge control module to perform its self-checks. This step is fundamental because it ensures that the diagnostic systems have ample time to detect any existing problems within the fuel gauge sending unit and its circuitry. If the error persists after this initial step, further inspection and testing of the components involved is required. This procedure sets a baseline status of the vehicle's diagnostics, crucial for identifying true issues in the fuel level sensor circuit. The second troubleshooting step requires disconnecting both the fuel tank unit connector and the gauge control module connector. This action allows for direct inspection of the physical connections and wiring between these important components. The fuel tank unit connector, with its 4 pins, is crucial for signaling fuel levels, while the gauge control module connector, which typically has 32 pins, is responsible for processing and displaying this information. Prior to proceeding with further diagnostics, ensuring that these connectors are clean and free from corrosion or damage is vital. Once disconnected, technicians can perform further tests to identify any continuity issues or failures within the wiring harnesses related to these components. This step is vital as it lays the groundwork for inspecting electrical signals critical for an accurate fuel gauge operation. In this third troubleshooting step, technicians conduct an open wire inspection focusing on fuel gauge plus and fuel gauge minus signals. Using a multimeter, they need to measure resistance across the open wires, looking for conditions that indicate less than 1 ohm. This means that the wires are in good condition and allow electrical current to pass freely without interruption. If the readings show significantly different values, it indicates an open circuit, potentially leading to the DTC B1175 being stored. Such inspections are crucial for ensuring the integrity of the electrical wiring that connects the fuel gauge sending unit and the gauge control module. Identifying any breaks or shorts in the circuit helps clarify if the issue resides within the wiring itself or an individual component. Consistent readings ensure confidence in the electrical integrity, and any discrepancies warrant further investigation or repair. The fourth step involves inspecting the gauge control module itself to determine if it is functioning correctly. If the open wire inspections in the previous steps led to normal conditions, the gauge control module may be deemed the root cause of the issue. Technicians will need to use diagnostic tools to further assess the module's operational status, checking its ability to process incoming signals from the fuel gauge sending unit. If the module fails to provide a proper output or shows signs of malfunction, it may require replacement or repair. This module is pivotal in ensuring that the fuel gauge functions accurately. Thus, confirming the module's integrity is essential for resolving the B1175 DTC effectively. Comprehensive testing at this stage is critical, as this could be the final piece to the puzzle in rectifying the fuel level sensor circuit issue. After completing the necessary repairs, it is important to verify that the diagnostic trouble code, DTC B1175, has been cleared from the system. This is typically done using a diagnostic scan tool that connects to the vehicle's onboard computer. Once confirmed, the next step is to check the fuel gauge function to ensure that it operates correctly. Testing involves cycling the ignition and observing the gauge's response to changes in fuel level. If the gauge provides accurate readings across various fuel levels, it indicates that the repairs made have resolved the issue once and for all. Following this verification step ensures that drivers can rely on their fuel gauge once again, effectively preventing potential issues such as running out of fuel. Proper documentation of repairs and successful test results solidifies a comprehensive repair report for references in future assessments. Preventive maintenance is crucial for avoiding issues related to DTC B1175 in the future. Regular inspections of fuel sensors will help identify worn or damaged components before they lead to catastrophic failures. This process includes checking connection points, wiring, and ensuring that the fuel gauge sending unit is clean and operational. Maintaining clean electrical connections is equally important. Corrosion or dirt can lead to miscommunication between electronic components, resulting in inaccurate readings or DTC storage. Simple steps, such as treating the connectors with dielectric grease, can help enhance their longevity. Being proactive about these maintenance tasks helps ensure that the fuel gauge operates without interruptions and protects against unexpected engine performance issues related to incorrect fuel readings. In summary, understanding DTC B1175 is vital for addressing and resolving issues related to the fuel level sensor circuit. This code signifies a malfunction that can lead to inaccurate fuel readings, posing risks for drivers. By meticulously following the outlined troubleshooting steps, technicians can accurately assess and remedy the problem, whether it lies in the wiring, fuel gauge sending unit, or gauge control module itself. Additionally, implementing preventive maintenance practices is essential for long-term vehicle health, helping to mitigate similar issues in the future. Being diligent in both troubleshooting and maintenance ensures a reliable fuel system, ultimately enhancing overall vehicle performance and driver safety. Knowledge of this diagnostic process empowers technicians and vehicle owners, enhancing the vehicle's operational readiness and reducing unexpected breakdowns. Please like and subscribe to the channel. See you next time.